Hello class, today I'm going to teach you how to find the percent of increase and the percent of decrease. So we're looking at the percent of change. Okay, this percent of change is the percent that a quantity changes from the original amount. So you take the percent of change equals the amount of change over the original. So here, when we have a percent of increase, okay, you take the new amount minus the original amount, get an answer, and then divide it by the original amount. When you find a percent of decrease, we're also going to subtract the new numbers. We're going to take the original amount minus the new amount over the original amount. So let's see how this works with numbers. Okay, the table shows the number of hours you spent online last weekend. What is the percent of change in your time spent online from Saturday to Sunday? So I can see it's a percent increase. So I'm going to subtract the two numbers and then put it over the original, which was Saturday, which is 2. So 4.5 minus 2 is 2.5 divided by 2. 2.5 divided by 2 is 1 25 hundredths. So move your decimal 2 times to the right. So we have 125% increase from Saturday to Sunday of your online time. Okay, find a percent of decrease. The bar graph shows the softball players' home runs. What was the percent of change from 2019 to 2020? So here are the two dates we are focusing on. I like to highlight them. And I'm going to subtract the two numbers. So 28 minus 20 divided by the original, which in 2019 was 28. So 28 minus 20 is 8 divided by 28. So when I got the decimal, I divided it out. The 8 drops in. 28's on the outside. I put a decimal, as many zeros as I need to. So 28 can't go into 8. 28 can go into 80 2 times. That was 56. Subtract 8, 7. That's 240. Bring down the 0. So when I finished it, I'm running out of room here, but on my paper when I finished it, I got 0.2857. So we want to round it to the nearest tenth. So move our decimal 2 times to the right. So we get 28.57. The 10th spot is where the 5 is. The 7 tells the 5 to bump up. So it's about 28.6% decrease. Okay, so the number of runs decreased by 28.6%. About. Then we have percent of error, okay? So it's an estimated amount, and we take the amount of the error over the actual amount. So here, modeling real life, you fill bags with about 16 ounces of homemade dog treats. So here are the bags, bag A and bag B. The acceptable percent error when filling a bag is 5%. Tell whether each bag is acceptable. So let's look at bag A, which is 15 ounces when you actually measured it. So 16 minus 15 over the original, which is 16. So 1/16. Pause the video, divide it out. Okay, my decimal, I got 0.0625. Move our decimal 2 times to the right. So 1, 2. So it's about a 6.25% of error. So the acceptable percent of error is 5%. So we know bag A is not acceptable. Okay, the company does not accept that. They take it off the line. Okay, so now let's try bag B. So 16.5 minus 16 over the original, which is 16. So it's 0.5 divided by 16. Pause the video, divide it out. And I got 0.03125 when I divided it out. Move my decimal 2 times to the right, so it's about a 3.125% of error. So bag B is good. It's acceptable. It can be sold in the store. Okay, great job. Okay, you estimate that a baby pig weighs 20 pounds. The actual weight of the baby pig is 16 pounds. Find the percent of error. So we're going to subtract 20 minus 16 over the actual weight of the baby pig, which is 16 pounds. So 20 minus 16 is 4/16, which simplifies to 1/4. I know that 1/4 as a decimal is 0.25, which is 25%. So the percent of error in the baby pig's weight and what you estimated was 25% of error. I hope this video helped you understand about percent of increase and percent of decrease. Have a great day.